Hi, welcome to the Flat Level Show. It's another part to my Flat Earth series where I take proofs of the flat Earth and break it down. This took a lot of studying, a lot of learning, a lot of relearning. I worked hard on this. I hope it helps. I'm going to be talking about the sun, giving some facts and some fallacies they tell us. I'm going to be explaining a little bit of how the sun works, not in full detail, but just a quick breakdown. And I'm also going to be showing both sides of what they say versus what the truth actually. I'm going to try to make this video short so people can understand. I cannot fit everything into just one video. So if anything, I'll just make a part two series. Um, Without further ado, this is the Flat Level Show, The Sun. The sun on the flat Earth. This is a CGI image of the sun, of what they give us. You can clearly see it's CGI. They will even admit themselves CGI. And but this just gives you an idea, a rough estimate of what it could look like. But either way, this we don't know and we can't see because the sun is just so bright. And this is clearly a CGI image. This is what they tell us about the sun. This is some main facts they tell us. The sun is at the center of the solar system. Excuse me, which we know that's not true. It's laughable. Um, the sun moves around us, so the sun can't be in the middle. They say it's a nearly perfect ball of hot plasma. The sun radiates energy as light, ultraviolet, infrared radiation. All right. And they tell us the sun is 75% hydrogen and 25% helium. They say it's a ball of gas and plasma. Um, Also, hydrogen fusion does not produce enough light. That's how we know there's gases in the sky when it comes in contact with the sun, it makes different colors. That's how you get the sunset and sunrise, and that's why it looks, like a pinkish or orange or reddish. It's also because of electromagnetism. It all works in sync, basically, almost like a clock. Um, and I'll explain more of that later in this video. All right, they say that all stars, including the sun, are a hot ball of gas, mostly hydrogen. They say it also has smaller quantities of heavier elements like carbon, neon, iron, and then oxygen. When actually these gases are in the sky, in the atmosphere, um, we don't believe that that's in the sun itself. Sun comes in contact with these gases that's in the sky, and I'll explain more of that in this video. There are four states of matter. This means everything is made up of one of these states of matter. It makes up everything you see. So, and I'll explain more of that. Okay, plasma. Plasma is the first um, one key point about plasma is that it only exists if ionization happen, which is like a charge, positive electron charge, electrical charge, which gets into electromagnetism and solar wind, and I'll get into that more in another show. But as far as the sun, so basically, yeah. So the sun is a moving source in our electromagnetic field in our world. Goes around a circle, in like a circuit around the Earth, going around, changes the radius and the diameter, which is the seasons. Every second, the sun and gases in the sky ionizes, leaves behind a trail or daylight, which is plasma. Daylight and sunlight are two different things, but I'll get into that in another video. So real quickly, ionization is a process by which an atom or molecule acquires a negative or positive charge by gaining or losing electrons. So they tell us that this ionization happens within the sun, but it actually happens here in our atmosphere, because they tell us the sun is 93 million miles away, which is not. So that makes it much closer and much smaller. What's more is that for plasma, you need ionization, which causes a chemical reaction or energy reaction. So yeah, they even tell us that the sun can only happen when it's charged. So that basically means that it's electromagnetic. So I'll explain more of that. And so you can see the plasma through the aurora borealis. The solar wind moves through the sky, which they call a magnetosphere, which is eminently a magnetic field. They emit the sky magnetic field is a magnetic field. The result of the ionization of these particles can cause them to emit light of specific colors, like the aurora or sunrise, sunset. This is how all light works. Light is electromagnetic radiation, because remember, the sun emits radiation. But what exactly is plasma? Plasma is highly ionized gas. This is what you see when the sky comes in contact with these gases every moment. So the sun charges it in the sky with these gases in the air, and that's how you get these colors and lights, and that's how you get light. All right, so that means that we are in a magnetic field. That's how light works, through ionization. So the question is the sun actually gas? No, because the sky has gas, and that's how, like I said, you get that's how you get light, and that's how it charges. I'll play a video to explain more at the end. All right. So now this is interesting. I'm gonna get into this one now. So this is the layers of the sun. This is the sun, what they tell us, with the core being the inner layer, 15 million K. Then you have the radiative zone, 7 million K, convection zone, 2 million K. Then you have the outer layers, photosphere. And then see, as you notice, it's 6,500 K. Then the chromosphere is 4,000 to 8,000 K. Transition region is 8,000 to 500,000 K. And then the corona is 500,000 to 1 million K. So what this is saying basically here is that between the core and the outer layers, the inner and the outer layers in between, it's cooler than that. So the outside is hot, the middle is the core is hot, and then in between that is cooler. So that makes no sense. Middle layers are colder than the core and the corona. They even say this is, they even say it's a theory of how they think the sun works. They give us all this math, numbers, science, in hopes that we don't see it. But I do. This is what I'm showing here. So they say, like I said, the core is hotter, is the hottest, and then the outside is hot, and then in between is not as hot. So they kind of explain it through, they say it's hydrogen fusion, nuclear or fusion or something like that. I have to check it, look it up. But basically, that's what they're saying, and then that means that it's a process that is going through. So that's why it's. But in reality, this will never happen. This can't work like that. Not even machines can do that unless they're specifically designed like that. But I'm not going to get into that. Next one. Okay, the temperature, like I said, they admit once again that they don't even know how the sun conducts heat. There's the core, which is supposed to be the hottest, the chromosphere, there's photosphere, and the radioactive zone, transition zone, and convection zone. The photosphere and the chromosphere, which are in the middle layers of the sun, are cooler than the core and the corona. And the moon is its own light, but I'm going to get into that in a whole nother video. So this here is what they say. Once again, the earth is supposed to be or look like. And you see the problem here. So if the middle is hot, how can it be, and I don't have the photo here, but I'll post it later. We only can dig 8 miles below the ground. We don't know what's below that, and there's no way of telling. But I'll get into that into a whole nother video if you have any questions. Okay, next one. Sunlight and daylight. The sun emits light. They say we can observe this with our own eyes through the visible spectrum, which is mostly white from space. When the sun is low in the sky, atmosphere scattering renders the sun yellow, red, magenta, which they tell us it's from the sun, but it's from scattering, from light scattering from the sun, which is not, which is actually the gases that are doing it in the sky. Okay, sunlight on top of Earth's atmosphere is 50% infrared light, 40% visible light, 10% ultraviolet light. I would have to get into that in another video because that gets into light spectrum, or it's kind of the same, but it just gets more deeper. But this is a game changer here. Light is a visible spectrum, refraction and reflection. Like I said, I'll get into it in another, I'll make a specific video about light and refraction and reflection and even perspective. So standing on the ground, when you see sunsets, especially in the summertime, you can see the glow and the rays from the sun light spread out. And I'll show that at the end of this video. All right, we kind of went over this already again, but here we go. The sun moves around the sky, charging the air and gases, thus ionizes and lighting up part of the earth. The sun is small and local, like a street lamp. It creates an umbrella effect. This is the plasma and what they call corona. It doesn't reach all the way across the plane, the Earth. It's local, and it goes around in a circle. Here's an example here. When you're seeing here, what you're seeing here is not a sunset. The sun never sets. So as it, like I said, it goes around, and as it goes around, it charges up the gas particles in the air, and that's how you get the light through it. And then the air itself, everything around us, the whole world, Earth, is electromagnetic. All right. Hydrogen molecules, atoms, and energy. According to science, while this may be true, everything is literally made up of atoms and molecules. You can have solid single materials or combine them into molecules, and we have elements as well. Um, Atoms contain nucleus and electrons and protons and neutrons. Neutrons. And this is what light is. Light is basically molecules, and it's a chemical reaction. Everything is molecules and atoms and the elements, and it goes through chemical reactions. This is how we make things, cook things, heat things, lose heat, combustion engines, goes on and on. And this is also connected with the light that you see, because this is energy. This ties into energy, but I'll get into that in another video, a whole nother video. Here's an example right here. I would have to do some more research on this because I'm still looking this up, but this is what they tell us it looks like, and what an atom is, and what everything has atoms, and everything is made up of atoms. So this is why I show this, but I'll explain more in a different video. Yeah, because the rabbit hole goes pretty deep. So the next one we got noble gases. This is what, like I said, charges the sun charges the gases in the air. Noble gases are already in the air, and it charges up the sun. The sun charges up the gases as it passes around us. The higher you go up above the ozone layer, about 12 to 30 miles, gases will separate according to the weight. So you have helium, neon, argon, etc. rise above the ozone layer and layer out. These gases generate electromagnetic field when ionized. In conclusion, you need elements and electromagnetism to produce sunlight. Here's an example of that. You also have diffuse light, which ties into the plasma and like daylight and the sunlight. Well, daylight, because sunlight is the actual light from the sun shining down. Daylight is just the plasma afterwards. It's like an after effect. So yeah, I'll get into the temperature in another video. So basically here, when you mix these gases in the air with there's oxygen, nitrogen, other noble gases, They get ionized with electrons. That's how you have the light. Also, the temperature can affect this depending on the season, the weather. So the gases are the sun comes up around the magnetic field, exciting these gases and emits light, photons, energy, or plasma, which is basically almost the same thing. All right, next up, the etymology. Sun has antiseptic properties like vitamin D. The corona plasma is daylight. It's how we got Sunday, literally. This may be why you see evil and everything going on today. Started from that, and which, in my opinion, disobeyed God, but they worship the God, the sun, as God. So that's just a thought. Yeah, because I was doing research and about the Greeks and how they saw the sun, how they worshipped it, and I did a bunch of translation and just went back and just looked up a bunch of where the roots came from. And basically, like, I'm not going to get too much into it in this video. I'll save it for another video because I just want to keep this about one thing. But I do have thoughts on that. Everyone has their own opinions. I have mine, so I'll make another video for that. Because it's not like I don't want to argue with anybody about it. I just want to, talk about it and, see where everything is and kind of analyze it. So the next up we have, this is just the ending here. Next videos I'm gonna be talking about like the poles. There's 4 poles: sound waves, light waves, gravitational waves, tides, the moon, curvature as well. And I already talked about horizon in the last video, so if you haven't watched that, please check it out. So this concludes my presentation. I hope this made sense. If you have any questions or comments, please leave a comment. You can email me if you like. Check out all my links. I have all my links posted. And I'll be starting my next video right after this, and then hopefully that'll be out soon to further go into this and talk about this. And yeah, hope that helped. Have a good day.